Welcome to the third and final video for section 4.4. We only have 3 examples to go through, and actually this will not take near as long as the other videos, or I'm sure hoping that it doesn't. I do apologize for the length of this, but there's a lot of stuff. Well, actually it's just involved problems. So we start off with number 9, and we need to find inflection points and maximum and minimums and stuff like that, and then draw a rough sketch. Now the nice thing about this problem is some of the fractions are so very bad fractions that I'm going to allow you to do approximations on this one. And you'll see why here in just a second. So we get y equals x to the 5th minus 4x to the 4th minus 200. And the first thing we need to do is the first derivative test, which is y prime. So that will be 5x to the 4th minus 16x cubed minus 0. And we need to find out when does this equal 0. Well, set it equal to 0. 5x to the 4th minus 16x cubed equals 0. We can pull out an x cubed everywhere, and we're left with 5x minus 16 equals 0. So x cubed equals 0, which means x equals 0. Or 5x minus 16 equals 0, which means 5x equals 16, or x equals 16/5. Now this is where we start to run into problems, because now what we need to do is, since this is where our potential maximums and minimums occur at either 0 or 16/5, we need to plug in some values. So I'm going to plug in -1 there, 1 there, and let's see, 4 will work here. And plugging it into the original, -1 will be -1, minus 4 is -5, minus 200 is negative. So we've got that much. We plug in +1. It's 1 minus 4, which is -3. -3 minus 200 is negative. So nothing really happens here at 0. Well, I mean, something happens, but not not a maximum. And then if we plug in 4, we get 4 to the 5th power minus 4 times 4 to the 5th power minus 200 equals negative here. So what this is saying in this problem is that everything's going down. And so if everything's going down, then you know, it's decreasing here, and decreasing here. There is no minimum or maximum. So it's, you know, it's going to look something like this, or maybe it's going to look like this. And we should look at this x to the 5th. It's going to have this general shape right here. So good enough for that. Now we need to find the second derivative. So the second derivative, taking the first derivative, would then be 20x cubed minus 48x squared. And where does this equal 0? Well, once again, we just set it equal to 0 and check. So let's see. You know what? I plugged the values in wrong here. Let's go back. Hold that horse up. Because I took it back to the original instead of the derivative. So let's try -1. -1 here would be +5 and positive 16. So that is positive. So that means this has to be increasing. Should have known something wasn't quite right. Plugging in 1 into here, we get 5 minus 16, so that's negative, so that is still decreasing. And at 4, let's see, plugging in 4, we get 5 times 4 to the 4th minus 16 times 4 cubed. And that's positive. And so this will be positive, which means this has to be increasing, and this makes a whole lot more sense. So we know something happens at 0 something and at 16/5 something, and this is where rounding is going to help. Now 0 minus 0 minus 200 is -200. So something, well, actually, since it's increasing and decreasing, that means this is a maximum. 0, -200 would be a maximum. And 16/5, let's see, if we just plug in 16/5 into the original, this is where taking it to a decimal is going to be perfectly fine, and then do an estimation. So it's 3.2 raised to the 5th power minus 4 times 3.2 raised to the 4th power minus 200, and that equals negative 284, more or less. I'm just going to let it live at negative 284. So this would have to be a minimum. So we know this is a maximum and this is a minimum. Now we come here back to where we were. Taking this, I need to set this equal to 0. And so I can factor out, let's see, I believe 4x squared, which leaves 5x minus 12 equals 0. Set each one of these equal to 0. So x would equal 0 here, and 5x minus 12 equaling 0, 5x would equal 12, so x would equal 12/5. And once again, we have to find what's going on here. So 0 and 12/5, so I can throw in a -1, a 1, and a 3 back into y double prime. So if I plug in -1, I get -20 minus 48, that's negative. So that means this is concave down. At 1, I get 20 minus 48 is negative. So it's still concave down at that point. And at 3, if I plug in 3 here, that would be 20 times 27, doing some mental math, minus 48 times 9. And that's a positive. So here it would actually be concave up. So now we have this information here. We've already determined something happens 0, negative 200. And then at 12/5 we're going to have to come up with yet another point. 12/5, plug that into the original, and once again this one's going to be allowed to have a decimal approximation. So 2.4 raised to the 5th power minus 4 times 2.4 raised to the 4th power minus 200, and we get negative 253, more or less. So now we have all of these values, and we just need to draw the graph so that it looks right. So I'm going to put in the points that I know first. So 12/5, negative 253, right there. And that's an inflection point, point of inflection. Then we have 0, negative 200, so that's going to be maybe somewhere here. This is a maximum. And at 16/5, which is over here, 16/5, negative 283, so right here. Now, we need to make it concave down here from negative infinity forever. So that sort of makes sense, you know, it goes like this, and then something happens right there. What happens right here? Well, then all of a sudden it becomes concave up, and so it becomes concave up from that point forward. So we get like this. And so now we look, this happened to be a relative maximum, this happened to be a relative minimum, and if you think about it, x to the 5th power should look something like this, or the other way. But this is what we're looking at in this particular example. Number 10. Number 10, we are told f of 2 equals 3. And we are told f double prime of x is greater than 0 whenever x is greater than 4, and f double prime of x is less than 0 whenever x is less than 4. So basically what we have here is at 4 something happens. We know that whenever it's to the less than 4, we know it's negative, and when it's to the right, it's positive. And since this is the second derivative, this tells us this is concave down, this is concave up. And otherwise, we know that there's a point f of 2 is equal to 3. So all we have to do is find the point 2, 3. This is not necessarily a maximum, and it's not necessarily a minimum. But what we do have to realize is that from 4 on, it's concave down. So I need to somehow make it concave down the whole entire way up until here. And then from this point forward, it's concave up. And so that means if I make it concave down, all I have to do is make sure that it is like that. Then right at this point, it has to become starting to do concave up. So it doesn't really matter how I do it, as long as I don't do any other sort of curves or bends anywhere else. This is a continuous curve with those properties. And so this is sufficient. Realize yours may not cross the x-axis, yours should cross the y, but it may not cross the x-axis. It could have just easily floated up here and done one of those things. So realize nobody's should look the same. Even if you wanted to, you could have it cross here at 4, 0 if you really wanted to. But the point is, the only point we know for sure is on this graph is 2, 3. And then make sure it's concave down for that distance. And then starting here at 4, x equals 4, we need to have it concave up. And finally, question number 11. Question 11 gives us several points. We have A through G. So I'm going to just write each one of those down. A, B, C, D, E, F, and G. And this is a graph of F, or Y. And we're asked, what type of value would Y prime have and Y double prime? In other words, would it be positive, would it be negative, or would it be 0? And so it's just a matter of determining each one of these. Now, if we look at A, first of all, that's not even differentiable, which means there is none. So this does not apply. Now, also, if the first derivative isn't there, then guess what? The second derivative can't happen either. So that one's pretty simple. Now, just so that I don't have to keep on bouncing back and forth, I'm just going to look at the first derivative. Now, looking at a graph, what we want to look at is for the derivative, we want to look at the slope. So at point B, what does the slope of that line look like? And to me, that is certainly, since it is a minimum, it has a slope of 0. So the slope is 0. At C, if we drew a tangent line, we would see that the curve or the tangent is actually positive at C. At D, that's an inflection point. But if we tried to draw a tangent line, it would end up being a horizontal line, which means it has a slope of 0. At E, we're going positive on the slope, so that becomes positive. At F, since that's a maximum, we have a slope of 0, or the tangent would be a horizontal line. And G, we're going downwards, so G would be a negative. So this explains all of the slopes. Now, Y double prime, we need to look at that particular point, is it concave up or concave down? If it's concave up, it's positive. If it's concave down, it's negative. And if it's an inflection point, in other words, it's going from concave up to concave down, it's 0. So let's look at B. If we look at B, during that time on both sides, it's concave up on the left side, concave up on the right, so that means it has to be concave up. So this would be positive. At C, this seems, if we look at C, on the left-hand side it seems to be concave up, but on the right-hand side of C, it is concave down. So that means it's 0. At D, we are coming into D concave down, and we come out concave up. So the derivative there would be 0 as well. At E, once again, coming into E concave up, Going out, we're concave down. So that would be 0 there. At F, coming into it, we're concave down. Going out of it, we're concave down. So that would be a negative there. And then G appears to be an inflection point because we come into it concave down, and then we end up concave up. And so we get the values of 0. So this is a pretty succinct table of what number 11 is asking for. And once again, how I would do this is for y prime, I would look at the slope, and for y double prime, look, is it concave up or concave down?